Yeah, welcome back, friends. In our previous session, we were discussing regarding carboxylic acids. Now, to discuss also all the reactions involving the carboxylic acid. And in this session, we start our discussion regarding the derivatives of carboxylic acid. Now, kama unavyojua derivatives of carboxylic acid ziko nyingi, including the acyl chloride, acid anhydride, the amide C, and other compounds which we discuss in this part. So we have acyl chloride, you have acid anhydride, you have amide and ester. Hizo ndizo ambazo tutadiscuss. So tutakuwa nasoma compound, tutakuwa nasoma nomenclature, tutakuwa nasoma preparation, properties pamoja na reactions za hizo compound. Let's start with acid chloride or acyl chlorides. These are the derivatives of carboxylic acid obtained when hydroxyl in the carboxylic acid is replaced by chlorine. As we know the general formula of carboxylic acid, it is RC double oxygen then hydroxyl. So if it will be RC double O then chlorine, that means hydroxyl is replaced by chlorine. And this derivative is called the acyl chloride, a derivative of carboxylic acid, So these are the derivative of carboxylic acid with a functional group of C double oxygen then chlorine. So acid halides, they have a functional group of C double O X acid halides. But here we are specifically talking of a chlorine, not all halides. So we'll be dealing with the chlorine, and we can say that the general formula of this acid halides, it is CnH2n minus 1, then it is X, like this way, CnH2n minus 1 X. So nomenclature, there is oxygen here, H2N O then X. Nomenclature hawa acid halide pamoja na acid halide nomenclature yake. Kwa mfano hapa anakuwa anaitwa ethanoyl chloride. Ethanoyl, unaweza kuona jinsi ambavyo tuna name hii group ethanoyl. Hiyo ethanoyl, eth ni kwa sababu ya carbon mbili. Ethanoyl, bromo, kwa mfano hiyo hapa ni bromo, then 6-methyl benzoyl bromide, 2 bromo 6-methyl benzyl bromide. Kilichopo ni kwamba ni bromine hapa iko kwenye carbon ya mbili ya pili, alafu 6-methyl benzoyl maana yake ni hapa. So kianza moja mbili kuzunguka hivi na kuzunguka hivi, bromo B yuko mwanzoni katika alphabet kuliko C, so tutazunguka kwenye bromo kwa sababu yuko mwanzoni. Then hapa itakuwa ni methyl benzoyl bromide. Lakini kwa mfano hapa ni benzoyl chloride. Benzoyl chloride ni acid anhydride derivative of benzoic acid. Na tuna nyingine kama hapo 3-phenyl 2-enoyl chloride, 3-phenyl 2-enoyl chloride. These 2 enoyls because of this group. So 3-phenyl, that means window parent chain. We hapa ni attached group, tunakuwa tuna 3-phenyl then 2-enoyl chloride. Mfano hapa ni propanoyl, that means na carbon 3, propanoyl bromide. Then hapa anakuwa ni anakuwa ni 1 2 3 4 ni 1 2 3 ni butanoyl chloride, lakini ana methyl kwenye carbon ya 3. So 3-methyl butanoyl chloride, 1 2 3 4, so butanoyl chloride, unaona. Alafu toka hapo huyo hapo 4-methyl benzoyl chloride, parency double O chlorine, for methyl benzoyl chloride. Unaona, you can observe the position of methyl group and this benzoyl, manake ndo huyu yote anaitwa benzoyl. So this is methyl. Then 2 in bracket 2 bromophenyl ethanoyl chloride. Naona bwana. Kwa hiyo nomenclature tunaonemo wanakuwa kama hivyo, wanakuwa na noyl. A preparation of acyl chloride. Kwanza ni reduction of carboxylic acid with phosphorus pentachloride, thionyl chloride or phosphorus trichloride. Example tunachukua na hiyo hapo plus ile pale nenda kupata ile plus wale product. Tunachukua na hii plus hii hapo nenda kupata hii plus hii product. So katika hii reaction inayokuwa replaced is hydroxyl group. This reaction is the same as how it occurs in alcohols that we discuss. Kwenye carboxylic acid, kwenye alcohols it can react with thionyl chloride or phosphorus pentachloride to give the same products. Kwa reaction is the same na product zinazotengenezwa pia they are almost the same, hata kama sio zile zile, lakini product zinazotengenezwa ni zile ambazo chlorine media attach pale. So that is a reduction of carboxylic acid with a chlorine compound hizo. That's one major method to prepare the acyl chloride, and because these derivatives of carboxylic acid we don't study them much, so there is no more need to know other reactions of these derivatives of other preparation of these derivatives of carboxylic acid. Now we can move to the chemical properties of acyl chloride and finally the reactions. Kwanza kuna nucleophilic substitution reaction. Nucleophilic substitution reaction. Acid chloride undergo nucleophilic substitution of the chlorine atom with nucleophiles such as water, ammonia, amine, alcohol, and benzene and alkali halide. Na hawa hapa wana uwezo wa undergo hii reaction faster kwa sababu ya attraction of the electron and delocalization of the electron by chlorine, which is more electronegative. The high reactivity of acyl chloride is due to the negative inductive effect of the carbonyl group on the chlorine atom. However, aromatic acid chloride are much less reactive. Aromatic acid chloride are much less reactive than aliphatic ones due to the reduction of the positive nature of carbon caused by the negative mesomeric effect of the carbonyl oxygen. Kwa hiyo tukiwa tuna aromatic acyl chloride zinakuwa ni less reactive compared na aliphatic, kwa sababu katika aliphatic ile inductive effect caused by chlorine inakuwa more stronger as compared to the inductive effect caused in this compound, kama kukiwa kuna oxygen, which will cause the positive mesomeric effect and thus reduce the inductive effect caused by chlorine. So the general equation tunaweza kusema kwamba huyu hapa react na nucleophile, tunakuja kupata nucleophile yaji attach pale, then tunakuwa tuna electrophile attach na chlorine, where R ni alkyl group. So we may have several ways to explain this reaction, several ways ambazo tunaweza kuelezea reaction kama hii hapa, lakini the simple mechanism for this reaction, or the general mechanism for this reaction, is that first a nucleophile always tend to supply electron, and hii carbon hapa ndo ambayo inakuwa na electron chache, so electron will be attracted towards chlorine. This carbon will be slightly positively charged. A nucleophile will supply electron to carbon and will form bond to carbon. Finally, carbon cannot accept electron without breaking the bond between it and the oxygen, so that to leave the space for it to accept electron. But what will happen is that these electrons in chlorine will be supplied to huyo hapa ambaye ni electrophile, halafu electrophile ta break bond kwenda kwa nucleophile pale. Kwa finally manake kutakuwa kuna bond, kutakuwa kuna electrons zinaongezwa kwa nucleophile neutralizing this positive charge. Remember oxygen pale na oxygen na negative charge, unaona oxygen na negative charge. So what will happen ni kwamba huyu bond ata break, sha break atapelekea hii hapa carbon iwe na uwezo tena ku accept electrons from oxygen. So further na kuna compound kama ile. Hizi ni reaction ambazo zinakuwa zinatokea in a few steps as compared to other reactions ambazo tungeweza kudescribe reaction mechanism yake katika steps nyingi. So katika reaction tuko na result chemical properties. Kuna Friedel-Crafts acylation. Friedel-Crafts acylation hizi hapa acyl chlorides zinahusika. Tunaondoa chlorine, tunaiattach ile group iliyobakia kwenye benzene ring in the presence of Lewis acid. Unaweza kuona some few examples of this reaction. We also discussed this in benzenes. Lakini pia reaction mwingine hapo ni reaction with water. Reaction with water. Acyl chloride they react with water to form carboxylic acid. Naona reaction with water. Then from there we have a reaction with ammonia. Acyl chloride they react with two molecules of ammonia. The acyl chloride they react with the two molecules of ammonia. To form amide. Kwa zinatengeneza amide ambayo inakuwa ni RCOONH2. Hizi ndio amide. Acyl chloride zinaweza react kwa style kama hiyo hapo. Then tuna huyu hapa, hizo ni examples. Reaction with alcohol inaitwa Schotten-Baumann reaction. The Schotten-Baumann reaction. Alcohol they react with acid chloride to form ester. Schotten-Baumann reaction ambayo is one among the reactions of alcohols ambazo kwa discussed inaenda kuform ester. Unaona example ni hizo hapo za Schotten-Baumann reaction. Lakini pia kuna reaction with alkaline solution. Acyl chloride react with alkaline solutions such as sodium hydroxide and potassium hydroxide to form carboxylic acid, such that tukiwa na huyo hapo tunakuja kupata carboxylic acid pamoja na sodium chloride pamoja na salt. Hiyo ni reaction with the alkaline solutions. Alafu kuna reaction with the phenol ambayo acid chloride react with phenol under the presence of strong alkaline solution to form ester. Ina form ester. Kwa hiyo phenyl benzoate au compound kama ile pale, phenyl benzoate is just like an example. Phenyl ethanoate, hizo ni baadhi ya ester mbalimbali. Lakini pia huyo hapo ukimreactisha na ukimreduce na hydrogen in the presence of vanadium catalyst unapata alcohol. Reaction of acyl chloride with vanadium catalyst. You reacting it with the hydrogen in the presence of vanadium catalyst. Reaction with carboxylic acid salt, RCOO sodium. Acid chloride react with carboxylic acid salt to form acid anhydride and RCOO sodium. So tukireactisha na carboxylic acid salt tunakuja kupata acid anhydride ambazo kuna kama huyo hapa ethanoic anhydride, kuna huyo hapa ni benzoic anhydride na acid anhydride wengine ambao wanatokana na reaction of acyl chloride with the carboxylic acid salt. A reduction of acid chloride reduction can be done by using the weak reducing agent such as the sodium tetrahydride bolate, or the strong reducing agents such as lithium aluminum tetrahydride in the presence of ether then water. So hiyo reaction ndio kutengeneza alcohol, na pia nimekwambia reduction kwa kutumia palladium catalyst in the presence of hydrogen tunaenda kutengeneza alcohol. Lakini another reaction is the Rosemond reaction. Another reaction is Rosemond reaction. This is the hydrogenation of acid anhydride and the presence of catalyst, usually poisoned palladium in the barium sulfate to form aldehyde. So inaitwa Rosemond reaction, ni reaction ambayo na reduction reaction of acid anhydride una reduce in the presence of hydrogen and the poisoned palladium catalyst in the barium sulfate. Kwa hiyo barium sulfate is poison, and that's why tukimix na palladium tunasema it is poisoned palladium catalyst. Tunaenda kupata alcohol and hydrogen chloride. If the catalyst is not poisoned, the acid chloride will undergo complete reduction to alcohol. Hii tunapata carboxylic acid, lakini kama tungetumia palladium yenyewe bila kuifanyia poisoning, basi tungepata jibu la mwisho ambalo lingekuwa ni alcohol. Naona alcohol reaction kama hizo hapo zinakuwa zinaonekana kama hivi, tumetumia palladium bila kuipoison, so tunaenda kupata final product ikiwa ni alcohol. So the acid chloride are mainly used as the acetylating agents in synthesis of ester, amide, acid anhydride, etc. So we may have a quiz here. Huyu hapa and huyu hapa, which one are the boiling point? Why? Give reason. The answer that carboxylic acid has a higher boiling point than this one. That's because of the ability of forming hydrogen bonds. Now let's go to discuss about the physical properties of this acid anhydride, the final part of finalizing about acid anhydride. Lower members of the acid chloride are colorless liquid with a pungent smell. Their boiling points are lower than those of the corresponding carboxylic acid because the acid chloride lack intermolecular hydrogen bonds, so they are generally insoluble in water. Boiling point ni lower, insoluble in water. The reason again, the hydrogen bond, they are generally insoluble in water, but the lower members will be hydrolyzed and therefore will fully in most of their densities is higher than that of water. Unaona, melting and boiling points of some acid chloride, baadhi tu ya ethanoid chloride pamoja na propanoid chloride. Actually these are not important for you to claim, maybe they will appear anywhere in the exam. No, they can't appear in the exam. It is just to show you the melting and boiling point of this acid chlorides. Unaona, so this marks the end of our discussion regarding the acid chlorides and or acid chlorides. So the coming session will be discussing regarding the acid anhydride. We will be having the discussion regarding the acid anhydride and how they can be prepared and they react in the laboratory. So thank you, and let's meet in the coming session.